Hello and welcome to video 11 in my Rigging in Maya series. We're really coming along with this rig now. In fact, I think the only area left to explore is a facial rig. Before that though, I think there is one more thing we can do with this one. Previously, we explored adding roll joints which allowed the limbs to deform in a much more natural way. As you can see, we can rotate the shoulder and the upper arm gradually deforms down to the elbow. The same happens with the wrist. As we twist it, the forearm rotates instead. While we're working on the limbs, it makes sense to stick in this area and add an extra feature. And this may not suit this type of character model, but it seems like the perfect time to demonstrate the technique. If we look at how the arm works now, if you move the IK control away, the arm stays rigid, as you would expect. So why don't we now look into making this limb stretchy, so the wrist is essentially always locked to the control. Now before we dive in, I just wanted to mention that you can now download all the source files for each part of this Rigging in Maya series from my CubeBrush page. You can find the link in the description below. While you are there, why don't you grab some of the other tutorials, models or rigs I have on offer? Most are free, but if you'd like to help contribute to these videos, all donations are welcome. As an added bonus, I'm also giving away a script I've written especially for you. Now what this will do, it will take the hard work out of rigging a limb. You simply press a button and you have an instant limb which blends between IK and FK and is also stretchy. Stick around and I will tell you how to get your hands on the script later in the video. Okay, let's dive in. In order to work out when the arm needs to stretch, we need to find out how long the arm currently is. So we need a way to work out the distance from the shoulder to the elbow and from the elbow to the wrist. This will give us the full length of the arm. We then need to also work out how far away the IK control is from the shoulder. Once we have these two distances, we can then check the IK control, and if it moves away from the arm, so if the distance is greater than the length of the arm, we know it should stretch. Let's get the length and distance information first. We could use the main arm and get the length from the current joints, but the problem is when it starts to stretch, the arm length will change, and then we end up in a weird loop where the arm gets longer but the IK handle is moving away, but the arm length is then longer and we're not sure, do we stretch, do we not stretch? So yeah, as you can tell, it gets confusing for us, so it gets confusing for Maya as well. So first we need a dummy arm to give us the actual length. Go into the outliner and navigate to the left arm group. We can use the IK arm we created earlier. So create a copy, but make sure the arm is in its default bind pose first. Let's make this visible so we can see it, and delete those nodes too. So we know what this arm is, rename it so it has _stretch on the end. And make the size a bit bigger too. We now have this dummy limb which isn't going to move or deform, but this will give us the default arm length. Open the node editor and let's clear it. Drag the new scale joints over into it. I'll just reposition these. We now need a node to tell us the difference between each joint. And funnily enough, there's one called just that. Press tab and create a distance between node. Let's rename this too so we know what it's being used for. Duplicate this so we have a second distance node and rename this to radius length. We need two nodes because they take inputs from 2 points, and with this hierarchy we have 3. Actually, let's add stretch into these names too. By default, the attributes we need are hidden, so we need to connect these a different way. On the left humerus stretch joint, click on the output dot and go down to World Matrix and select World Matrix 0. Now click on the input dot on the humerus stretch distance node and choose Other. A window will open allowing you to choose what input you want to connect to, so select in matrix 1. Now do the same with the radius stretch joint. Choose World Matrix 0 as the output. Now choose Other again, but this time select in matrix 2 in the inputs window. As you can see, those attributes are now visible because they've been connected. What this node will now do is output the distance between the two using the distance attribute. That's the upper arm done, so let's do the same for the lower arm. You'll notice that the World Matrix attribute isn't visible this time. That's because we've already used it. So go to Other instead. We need to find it manually, but there's a lot of attributes here to sort through. Go to Display and then select Outputs Only. This will narrow things down for us. We can now select World Matrix and then World Matrix 0. Connect this to in matrix 1 on the radius stretch distance node. And connect World Matrix 0 on the wrist stretch joint to in matrix 2. Again, these attributes are now visible. We now have two distance nodes, one for each section of the arm, but ideally we just want one value, so we need to add these together. Create an Add Double Linear node. This will take the two values and add them for us. Rename this to Left Arm Stretch Length. Actually, I'll remove the stretch as this node is going to just hold the arm length. If I open this, you can see we have just two inputs and one output. Connect the distance attribute from the humerus stretch length distance node to input 1, and then the distance attribute from the radius distance node to input 2. This one node now holds the full length of the arm. Let's get the IK control distance next. So as mentioned earlier, we just need the distance from the shoulder to the control. So we could just use the control directly, couldn't we? Well, this doesn't always work, but let's see what happens. Add the IK control to the node editor, and let's remove the shape node. We need another distance node, so we can quickly duplicate this one. And rename it to Left Arm IK Distance. Let's use the humerus stretch joint again as our point of origin, so click on the output dot and go to Other. Go to Show Outputs and then select World Matrix 0. So this is the same as before. Connect this to in matrix 1 on the new distance node. On the arm IK control, select World Matrix 0 and connect that to in matrix 2. We now have this distance attribute which will tell us how far away the IK control is. Let's remove some of these nodes now, the ones we no longer need. Create a condition node, and if you've been following this series, you'll be familiar with these by now. Rename this to Left Arm Stretch Condition. We will quickly know if using the IK control directly has worked or not. So what we need is for the first term to be the IK control's distance, because we will need to compare that with the arm length. I'll just open this in the attribute editor. I'm going to change the operator to greater than, because we are checking to see if the IK control distance is greater than the arm length. So up here we will be watching for when the first value term goes over the second value. Connect the arm length output to second term. So there we have the value we are checking against, and we can see the arm has a length of 0.509. Now connect the distance attribute on the IK distance node to the first term. So I can see straight away that connecting directly to the IK control hasn't worked because the value is 0.673 and is too far away from the arm length. Ideally, we need that value to be as close as possible. Okay. Instead, let's create a locator and use that. This should give us a much more accurate value. Quickly parent constrain it to the IK control so it matches its position. Make sure maintain offset is disabled. I'll make it a bit smaller too. We don't need that constraint node anymore. And let's rename the locator to left arm stretch end. We now need that to follow the IK control, so parent it to it. Now add the locator to the node editor. Why are you all the way over there? Maze node editor does some weird things when you're bringing nodes in. Okay, so connect its world matrix 0 attribute to in matrix 2 on the left arm IK distance node. If we now select the condition node, you can see the values are much closer together, so this is exactly what we want. If I move the IK control away a bit now and select the condition node, we can see that the first term value has gone up. So what the condition will do is check for this, and when the value goes over 0.509, it will output the colour if true value here. If it's under, it will use the colour if false value instead. So with joints, their default scale value is always set to 1. So when the condition is false, the joints will stay at 1 because we don't want them to stretch. What we need now is a way to get a value which we can use to scale the joints. If we use the distance from the IK control, that won't work because, as you can see, the initial value is under 1, so we won't get a correct scale. Instead, we can use a simple bit of math to work out the scale. Create a multiply divide node. I'll just move this over here. Let's rename this to left arm scale multi. Connect the arm IK distance node's distance attribute to input 1x, and then the left arm length's output attribute to input 2x. What we need to do now is change the operation to divide. So we are dividing the IK control's distance with the arm length, which will give us the scale value we need. Connect output x to colour if true r on the condition node. We can see the value is higher than expected, but remember, the IK control has been moved away from the arm. So to recap, if the first term is above the second term, the arm is obviously stretching. So we use the colour if true value here for the joint scale. If the first term is below the second term, we don't need to stretch. So then we use the colour if false value, which is set to 1, the joint's default scale value. Let's connect these to the joints now and get them scaling. Now we don't want this to affect the main joints because we still want the flexibility of both IK and FK control. And as this is powered by the IK control, we should use the IK joints. Bring just the humerus and radius IK joints into the node editor. We don't use the wrist because each joint will scale down the bone, and if we include the wrist joint, that will also affect the hand and the fingers. Let's open these up so we can see the scale attributes. Looking at the joints, we can see they need to scale down the y-axis. So connect outColor R on the condition node to the scale y attributes on both joints. There we go. You probably noticed the arm changing as we connected them. As you can see, we can now move the IK control and the arm stretchers to make sure the wrist is locked to that control's position. Let's just turn off the texture to see it a bit clearer. And turn on wireframe 2 so we can see what's happening to the topology. So the first thing we can see is that the roll joints, which we added in the previous video, aren't being affected by the stretching. As a consequence, the geometry they're skinned to is being held back. We can see it on the wrist roll too. There are two things we could do. We could attach the stretch system to these joints so they scale too, but we might try something else first. So let's just reset that arm. Ideally what we need is for the roll joints to stay in between the ones either side. So this bicep roll will always be between the shoulder and the elbow. We could use a point constraint, which will do this quite well. But I try not to use constraints unless I really need to, because they can be temperamental and extreme poses. I'd rather try direct connections with nodes first, as these are much more solid. So first I'm going to duplicate the roll joints and move them out of the hierarchy. These are here purely for reference, so I can make sure the ones in the rig are in exactly the same position once we've set them up. Let's go back to the node editor and we'll just clear that. I'll hide the arm systems now too. Select the humerus and radius joints as they are the ones either side of the roll joint and bring them into the node editor. Let's open these up and move them here. Create a new distance between node. Let's call this left humerus length. We want to find the distance between the joints, so do exactly the same as you did with the stretch joints. Connect world matrix 0 on the humerus joint to in matrix 1. And world matrix 0 on the radius joint to in matrix 2. Now create a multiply divide node and call it left arm roll scale. Connect the distance attribute on left humerus length to input 1x on the multiply divide node. Bring the bicep roll joint into the node editor. We're going to use the multiply divide node to control where the joint is, based on the length of the arm. We can see that the Y translation is the attribute we need to control its position. I brought in the wrong roll joint. I selected the reference joint instead. Okay, let's bring the right one in and connect that up. So, connect output X to translate Y. Okay, that's better. The roll joint has now moved to the end of the arm, well, the end of the upper arm, because it's being told to move the full distance of the upper arm. What we can do now is adjust the input 2x value to change how much the roll joint will move. We should have it about halfway because that's where we originally created it. Yep, 0.5, so half the distance. Now we know that's in the right place, we can delete the reference joint. As we stretch the arm now, the roll joint stays between the shoulder and the elbow, which is exactly what we need to clean up that topology. Let's work on the lower arm now, and we can use the same multiply divide node. We don't need these joints, so let's remove them. And we will duplicate the distance node and then remove the old one. I'll change this to radius. And bring the radius and wrist joints into the node editor too. Right, let's connect these now. So if you remember before, when a joint was already connected, the world matrix attribute didn't show up. So let's go into other instead so we can track it down. So let's change this to outputs only so we can see it. There you are. And connect this to in matrix 1. Onto the wrist now. And we will connect this to in matrix 2. We can get rid of the bicep roll joint. As mentioned, we have more slots here we can use on this node, so there's no sense in creating another. So connect distance to input 1y. And we know that a value of 0.5 will place the joint in the right place, halfway between the elbow and the wrist. Now let's bring in the radius roll joint, the right one this time, and connect it up. So output y to translate y. So I'll just double check they're in the same position. Yep, looks good. So we can delete the reference joint. So as you can see, the whole arm stretches now, including the roll joints. Now the wrist roll is a different story. This doesn't actually affect the geometry. We only need its Y rotation for the rig, so we can leave this alone. If it bothers you though, you could, in this instance, simply point constrain it to the wrist joint. This should be fine, so long as you only use a point constraint and not an orient or a parent constraint. There we go, the arm is stretching nicely. There is one more step we could take to make sure the topology is as even as possible, and that's to scale the joints too. As you can see, it just spreads the arm out a touch more, making it look even smoother. The same with the wrist. Clear the node editor. And bring in the bicep and radius roll joints. I'll just open these up. We need to find the main stretch condition node. Where are you? Ah, there we go. So drag this in too and expand it. All we need to do is connect the outColor R attribute to both the joint's scale Y attributes, just like we did with the IK joints earlier. There, that looks a lot smoother. We have a nice distribution of edge loops down the arm. The wrist roll works well too. There we go. Fine when it's not stretched and fine when it is. Nice. Even though this works quite well, it does have a slight issue. You see, when the arm is stretched, we have this value on the roll joints, which is fine when working in IK. But what if we leave the arm stretched and blend back to FK? The scale attributes are still stretched, so the arm is now folding in on itself. There is a way around this though, so don't worry. All we need to do is disable the stretch when in FK. So let's bring back the node editor, and we can keep these in here for now. We need a new node, so press Tab and create a Blend Colors node. Let's rename this to Left Arm Stretch IKFK. Actually, let's add roll in there too. What this node will do is allow us to blend between one attribute and another. So effectively, we can control the stretchiness on the roll joints. Bring the left arm control node in next. We need the main IKFK switch attribute to drive this. Open this up and let's connect that to the blender attribute. Oh, hang on, that didn't connect. There we go. You can see the blender attribute is now at 0, like the IKFK control. Let's open these attributes. Connect outColor R to Color1R on the Blend Colors node. And then output R to the Scale Y attributes on the joints. The arm looks a bit weird now, but don't worry. We need to set Color 2R to 1 because that's the default value for a scale joint. So what this will now do is blend between the stretch value and the default scale value as the arm blends between IK and FK. If we switch to IK, the scale attribute has a higher value now because of the stretch. If we go back to FK, I should hide that IK handle, it's back to the default value of 1. So we can happily pose the FK arm and then go to IK and have a stretchy limb with nice even topology. Yeah, that works well. So let's reset these. Even though the arm is set up, there is one more thing we can do. Let's add a few extra attributes to give the animator even more control and freedom with how they control the arm and its stretchiness. We need to add these in because at the moment the arm stretches regardless of what you do, so we need to give the animator the ability to disable it. We are going to add the new attributes to the IK control, not the arm control, as these will only be needed when the animator is using IK. Go to Modify, Add Attribute. Let's make a divider first, so call this Stretch and make sure you have the data type set to enum. Remove the blue option and rename green to a series of dashes. It doesn't matter how many, as this is just going to represent a line. And let's add that. Let's also lock it and make it non-keyable. Let's add another attribute now, this time just to float. Call this Stretchiness and set the minimum to 0 and the maximum to 1. Finally, let's add another enum. Call this Stretch Type. Change the enum names to none and then both. Now add a third option called stretch, and for the fourth, use a few dashes again. For the final option, call it squash. You will see why we added the dash option later. So there, we can now choose how the arm will act. Those are the attributes added, now let's wire them up. Bring back the node editor and you should still have these nodes available. We can get rid of this control and this shape node. Just open these up and move them up here. We also need the original IK joints in here too, so let's bring those in. These are the ones with the main scale connection. Let's also open these so we can see the scale attributes. So we have the scale value coming out of this condition node. So we ideally need something in between which will allow us to turn it from the stretchy scale to the default scale of 1. And we have already done this with the IKFK blend we had just added. Let's duplicate that blend colors node and rename it to left arm stretchiness. I'm going to connect outColorR from the main condition node to the blender attribute. So as we saw earlier, the blender attribute will blend between color 1R and color 2R. Actually, this needs to go into color 1R, not blender, because this is the first value we need. The blender attribute should be controlled by the stretchiness attribute, so bring in the IK control. Just move this up here. So we just connect this to Blender so it controls whether it uses the stretch value or not. Let's now connect the output attribute to the scale Y attribute on the IK joints and see what happens. So the stretch value is now going through the blend colors node instead of directly into the joints. Let's hide this and try it now. So stretchiness is set to 0, so we shouldn't see any stretching. Okay, that's half working, which is great. The main joints aren't stretching, but we still have an influence over the roll joints. Let's bring back the node editor and correct that. All we need to do is change the input on the original blend colors node that we added when blending between IK and FK. Take the output R attribute on the left arm stretchiness node and connect that to the color 1R attribute. So basically, everything that stretches now goes through the left arm stretchiness blend colors node to see if it should stretch or not. That looks better already. We have no stretching now. We can also adjust the stretchiness attribute to blend between the limb being stretchy or not. What we can also do is still blend between IK and FK, and the stretchiness is updated automatically for us. So that's the stretchiness control added. I'll just reset the arm. Now let's look into adding the ability to change how the arm will squash or stretch. If we look at the main stretch condition node, I'll copy this tab so we can always see it and just close this. With the operation set to greater than, we can stretch the arm. If we set it to equal, nothing happens. Changing it to not equal gives us an arm that both squashes and stretches. And less than just gives us the squash. So you can see how altering the operation gives us these different abilities. Let's bring back the node editor. The operation attribute isn't visible here, so select stretch type and go to the condition node's input dot and then select other. We can see operation here, but if yours isn't visible, make sure show non-keyable is selected here. So all we need to do is select operation. So we can see that when this attribute is set to none, the condition node is actually set to equal, but the arm has no squash or stretch. If we change it to both, the condition node changes to non-equal. This is because they are connected and each item on the list is simply a number. So when stretch type is set to none, it's actually 0. So it sets the operation to 0, which in this case is equal. We are just giving them more relevant names to make it easier for the animator. Stretch is as we originally had it, so greater than, which stretches but doesn't squash. The dashes we added are actually a dummy option. This changes the operation to greater or equal, which essentially does the same as stretch. So we can ignore that and move to squash, which sets the operation to less than, giving us a squashy arm. Now this is just one approach to doing this. You could get the same results and remove the dummy attribute by using set-driven keys. Personally, I prefer to use utility nodes rather than adding lots more animation curves, but either approach works. There is more we could do with this arm. For example, we could add in volume preservation, which essentially makes the arm thinner the more it's stretched, or wider when it's squashed, but that's a bit more complicated. So what I will do is I will cover that in a future video when we start to look into more advanced systems. What I'll do now is I'll go through and update the rest of the limbs, so be back in a bit. So the eagle-eyed among you may have noticed that even with this setup we still have a slight issue, and it is just a minor issue really. If I move the arm around in IK and then we blend back to FK, everything looks fine. It deforms nicely and it blends quite nicely between the two. But now we've added in the stretch, if I then decide I want to blend from a stretched arm to FK, if we get about halfway, we can see we've got this issue with the wrist. It becomes disjointed. So if I show the actual joints, so we can see here, it's actually coming away from where the elbow points to the wrist. If I show the rest of the arm, I'll just bring these back. Let's have a look, make these visible. So we can see we have the IK and FK arm here, and all that's happening is because we've added in this stretch, we've ended up with some sort of offset, which is causing this issue. And again, like I say, if I move back so we're not actually stretching, or if I just turn the stretchiness off, everything looks fine. So it's just because we've added in that stretch and created this offset. Now I've tried playing around with a few ideas for fixing this. I tried a point constraint, that didn't work. A parent constraint, that didn't work either. I also tried adding in an IK handle to try and keep the roll joint pointing directly at the wrist. But again, that didn't work. And to be honest, it just started overcomplicating things. And then I suddenly realized most of the time when animators are working with this kind of rig, they literally, if they're blending between IK and FK, it's literally that. They just want to go from IK to FK. They never really use the blend in between. And most of the time, animators have a custom script which matches the IK to the FK. So it basically matches the position of the IK arm to an FK arm. So when you're blending between the two, you don't see any blend, and vice versa. So my solution to this problem is when you're creating the IK-FK switch attribute, if I just open up the add attributes here, instead of using a float like we have, use an integer. What that means is the attribute is literally just going to switch from 0 to 1. So you won't get a blend, you'll just get a snap. And what I've done is I've updated this rig, and this will be the rig that you're looking at in the asset files. And I've done this already. So I'm just going to load that in and show you how that works. So we have this new arm set up here, and I'm just going to stretch. And because our IK-FK only goes from 0 to 1, rather than getting the blend so we can see the problem with the wrist, it's just going to snap. So you're just getting that IK and FK swap without seeing the problem with the wrist in the middle. Now there are ways around that wrist problem, and that comes with a more advanced rig, which I'm going to show in the future, and that's a ribbon based rig. So you get a much more stable arm. But for this basic rig, I would recommend, if you don't want to see that issue on the wrist, just change this to a integer attribute, and then you can just snap between IK and FK rather than blending. And it just makes things a lot more solid. So there we have it. All the limbs are now set up so we can grab him and pull him around, and the hands and feet stay where they are. He's a bit like a Stretch Armstrong, if any of you remember what that toy was. Showing my age a bit there. All the other limbs have similar controls too, so we can also change how the stretchiness works. Okay, so let's talk about the script I mentioned at the beginning of the video, the one that I've created especially for you guys. Here we have the basic skeleton, which is skinned and the way it's painted. So there is currently no rig on this. Let's say you want to quickly rig all the limbs. All I do is open this tool. As you can see, we have lots of options here. We can work on an arm or a leg. We can also specify which side we want to build. Let's focus on the left arm for now. Another important aspect is to set the axis orientations. So primary axis is the one which points down the bone, so Y for this skeleton. Secondary axis is the one which points forward, and the up axis points, well, up. With those set, all you need to do is select the three main joints of the arm. I'll just open the outliner so you can see them. There we go, the humerus, radius and wrist. You have to select them in order. All you do now is click go. There, that's done. We have full IK control. We can also position the elbow. It also blends between IK and FK too. What's more, the arm is stretchy too. Plus, as you can see, there's some volume preservation going on here as well. As the arm stretches, it's getting thinner. I also added a volume offset attribute so you can adjust it. Let's set up the other limbs. So we select the 3 main joints of the right arm. Also make sure to set this to right and click go. Done. Another limb set up in seconds. Let's do the left leg now. Again, select the 3 joints first. Remember to change the limb type to leg and the side back to left. And click go. Another one done. Okay, last leg. Change this to right and again just click go. If your rig is a different scale, you can use the scale multiplier to adjust the overall size of the controls. Let's change this to 2. There you see the controls are bigger now. Let's try 0.5. And there they are much smaller. So, how do you get your hands on this script? Well, this is going to be the first of many rewards I have planned for people who regularly support me over at my Ko-fi page, which is ko-fi.com/antCGi. Your support is really important and it helps me to make more free content. So it's just my small way of saying thank you. So I hope you've enjoyed this video. If you have, please let me know in the comments below. Also let me know if you have any questions and tell me what future videos you would like to see. Remember to download the files from my CubeBrush page so you can follow along with these tutorials. And why not say thanks with a small donation via my Ko-fi page. As always, remember to like this tutorial and subscribe to my channel to keep up to date with future videos. This is antCGi signing off, and I will see you on the next one.